Hello, hi everyone. Am I audible? Let's just let me know in the chat if I'm audible. 16 people are there. So any one of them can let me know if I'm audible. Thank you. Hi everyone. Can anyone let me know if I'm audible or not? If I'm not audible. Hi MacDon. Are you asking this because I'm audible or because I started the stream? Like, am I audible? Just write yes or no. I am fine. Okay, Pradeep, thank you. So let's start with today's PCD. Yeah, so hi everyone. My name is Pradyumn Kejriwal, and today we'll discuss the today's Codeforces Round, Division 2, and we'll discuss the problems A to E. Before we begin, I will tell you about our courses at TLE Eliminators. So if you are someone who is trying to level up in CP, then our self-paced courses are exactly what you need. We have structured the program into 4 levels, as you can see here, so that you can start from wherever you are, like beginner, pre-intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through recorded video lectures, followed by carefully curated practice problems, combined with guided hints and detailed video solutions that will help you understand the why and not just the how. We believe in helping you build real intuition. If you need more help, then you'll get instant doubt support from our mentors on Discord. So none of your doubts are ever left stuck. And beyond learning, you can enjoy leaderboards, progress tracking, internal contests, and PCDs like this to keep you consistent. Pick the level that fits your goals and start learning today. So, if you want to understand that how to pick a level, then you can watch this video, which describes the same thing. And if you are still not sure, you can watch the level specific video. Like if you click on the level, you can watch this video, which tells you more about the levels, prerequisites, outcome, difficulty, and the topics that have been discussed. All right. So let's start with PCD now. All right. So today's problem A was MEX partition. Let a partition of multiset B be a collection of multisets S1 to Sk such that each element appears the same number of times in B and across all of S1 and Sk. For example, we can partition 1, 2, 2, 3 into 1, 3 and 2, 3. This is one partition. Or another way to partition it would be 1, 2, 2, 3. That is just include it in every, like, just include every number in one partition. And another way is this 2, 1, 3, 3, right? But not 1, 2, and 3 because 3 appeared twice in this, but only single time here. A partition is called valid if the max of all multisets in the partition is same. That is, all these multisets that are in the partition, all of those maxes have to be same. The score is the max of any multiset in the partition. That is, it is the same for all multisets, right? So whatever is the value, that is the score. You are given a multiset A of size n. Find the minimum score over all valid partitions of A. Okay. So what they are saying is, like, we have um, a multiset, right? Multiset A, and what we can do is we can partition it. Just a second. Yeah, we can partition this into multiple multisets, that is S1, S2 up to Sn or Sk, let's say. And what they are saying that it is valid if and only if the max of S1 should be equal to the max of S2 and this should be equal to max of Sk, right? Like all should be equal. And the score of this partition is defined as the value that is, like, whatever the value that is, this is a score, right? And we have to find out that over all the partitions, what is the minimum possible score, right? So let's try to understand what will happen here. So first of all, since this max is the score, right? Like our final score is the max of some sets, right? So of course, max is always greater than equal to 0. Like max of any set is always greater than equal to 0, right? It can't be negative, obviously, by its definition. So what we can say is, if we are able to get score equal to 0, then that is the minimum, right? So basically, we need to ask ourselves that when can we get a score equal to 0? Like if we are able to get a score equals to 0, then definitely we can say that um, that is the answer. Because of course we cannot do better than 0, right? So when can we get a score of 0? A score of 0 means what? It means that every multiset, like every multiset that is S1, S2 up to Sn or Sk, whatever we are partitioning it, all of those mexes should be 0. That is, mex of S1 should be 0, mex of S2 should be 0, and up to mex of Sk should be 0. So that means that none of those partitions should have a 0. So none of S1 to Sk should have a 0. Okay. So if none of them have a 0, then we will have score equals to 0, right? But the thing is that that is only possible when our original multiset did not have a 0. Like if we want that all of these multisets don't have a 0, then of course the original one also should not have a 0, right? So if the original one did not have a 0, then our answer can be 0, right? So if A doesn't have 0, then the answer equals to 0, right? Otherwise, any one of these sets would have 0, right? And therefore, our score would not be equal to 0, because we want the max of all of them should be equal to 0, right? So this is one thing. Okay, so now let's say, like, okay, if we don't have a 0 in the array A, then the answer is 0. But what if we do have a 0 now? That means that score answer equals to 0 is not possible, right? Like making the score equal to 0 is not possible. So let us try making it 1. Like if max equals to 0 is not possible, then what is the next value? Max molar value. Max equals to 1. Like we want to minimize the answer, right? And the answer cannot be 0. So let's see if it can be 1 also. Okay. So what we want? We want score equals to 1. And at this point, we know that A has at least 1 0. Right? So let's try if we can get score equals to 1. What does score equals to 1 mean? It means that the max of S1, the max of S2, like the partition that we are doing, max of S1, S2 up to max of Sk, all should be equal to 1. Okay. So what I am saying is that if we want score equals to 1, that means that the max of all of these sets, S1, S2 up to Sk, they have to be 1, right? That is how what a score is defined as, right? But one thing I can say for sure is that, let's say if the max of a set S is some value k, okay, then I can say that this set S does not have k, does not have k. Like if the max of a set is k, then basically it has all the numbers from 0 to k minus 1, 0, 1, 2 up to k minus 1. It has all the numbers and it does not have k. That's what max means, right? So if all of these sets, S1, S2 to Sk, if they are all 1, like if the max of them is 1, that means all of them don't have a 1. So S1, S2 to Sk don't have a 1. What does that mean? That means that A also cannot have a 1, because we partition A into S1, S2 up to Sk, right? So A cannot have a 1. Like if we want score to be equal to 1, then A can't have a 1. Right? That means if A has a 1, then definitely score can't be equal to 1 as well. Okay. And like at this point, we knew that A has at least 1 0, because otherwise the answer would be 0, right? So at this point, we know that A has at least one 0. And if we want the score to be 1, then A cannot have a 1 also. Right? So basically, if A has a 0 but not 1, then we can have an answer 1. Like, then it is possible to have a score equals to 1. And how can we achieve that? Then we can simply put all the elements into a set. Like basically, this is the partition. Like we don't partition the set at all. That means this 1 2 2 3. If this is the input, it will remain 1 2 2 3 only. This is a valid partition, right? So if we just partition it into only one multiset, then what is the max? The max of S1 is basically the max of A only. Max of A, right? And that is equal to 1. Because A has a 0 and does not have a 1. So max of A is 1. So like essentially, my entire argument is that if we want that the score is equal to 1, then A cannot have a 1. Right? And if I want that score equals to 0, then A can't have a 0. Right? So basically, if A doesn't have a 0, then score equals to 0. But let's say if A has a 0, but A doesn't have a 1, then score equals to 1. Because we can partition the entire thing into only one multiset. Then let's say it has both 0 and 1. Like it has both 0 and 1. So the score cannot be 0 or 1. And so what about 2 now? So if we want that score equals to 2, then of course A cannot have 2 by the same logic. And like if A has 0 and 1, but it doesn't have 2, then we can just put the entire thing into the same partition and we'll get a score equals to 2. So essentially you can notice the pattern that whatever is the smallest element that A doesn't have, that is our score. That is our minimum score that is possible. Because we cannot achieve a smaller score than that. Because that element will appear in at least one of them. Like let's basically formally what I'm saying is if A has 0, 1, 2 up to k, like let's say A has all of these numbers, right? Then my score cannot be equal to, like, my score is definitely greater than k. That is my point. Why? Because if we try to make score something less than equal to k, then that is not possible. Because let's say if I want to make the score equals to 5 and 5 appears in the array, then 5 will appear in some partition, right? Where, like, if I partition it into S1 up to Sk, then 5 will appear in some partition. And therefore, its max cannot be equal to 5. But I want the max equal to 5, so that is no contradiction. So score cannot be less than equal to k, it has to be greater than k. And so whatever is the first element, like k plus 1 is there, which is not occurring. So k plus 1 is the answer. Because we can just put all of the elements in one partition and the max would be k plus 1. So the answer would be k plus 1, or basically the max of A. Like whatever is the smallest non-negative integer that is not present in A, that is the answer. Okay. So I hope you understand this. And by now, I think many people have told me to go to the next question. Like I am not looking at the chat, but I am pretty sure that many people are there who are thinking at least that why is he so slow. So let us move to the chat now. Yeah. Okay. So do you guys get this? Like, is there any doubts? I will um, give you a chance to ask your doubts right now. Meanwhile, I'll show the code. So while I am showing the code, you can ask any doubts in the chat, and after showing the code, I will get back to you. I'll get back to the chat. Okay. All right. So this is a problem that I face many times. I don't know why. Let us try to open this. Okay. Let's try to turn on VPN. It is not loading. Very nice. Okay, meanwhile, any doubts? I don't think there's any doubts. Yeah, okay. So basically, the answer is just MEX, right? The answer is just the MEX of A. So you have to find out the MEX of A. And the easiest way to do that is to make a set. Like I'll make a set which has all the elements from 0 to 101. Okay. And I will just remove all of those. I'll remove all those numbers which are there in A. Like basically what I did is I just made a set which has all the numbers between 0 and 101, and then I erased those numbers which were there in AI. I mean, in the array A, which is the input, I just erase all those numbers from this set. And finally, whatever is the smallest number remaining in the set, that is my answer, right? Because that is the smallest number that did not appear in the array A, and that is the answer. That is the max, right? So that's the code. Okay. This might be possible, but am I? I am logged into the same account. Like this is what I have submitted. I don't know why it is giving that. Anyways, so let us move on to the next problem. So B is called distinct elements. Now this problem was like seemed pretty tough for a B actually. Like I don't know. It seemed kind of tough. What is the rating? Let us see. Okay, while this is loading, I think it is because of the VPN that is slow. I'll turn it off. Yeah. Okay, it is 1000 rating. So I don't know. It just felt tough. But anyways, given an array C, let f of C be the number of distinct elements in C. For example, f of 1 to 2 is 2 because there are two elements which are 1 and 2. Also define Cij as the subarray of C bounded by I and j. That is Ci, Ci plus 1 to Cj. There is an array of size n, an array B of there's an array A of size n. An array B of n elements is constructed such that Bi is f of A of 1 to I plus f of A of 2 to I up to f of A of I to I. You are given the array B. Find any possible A with elements between 1 to n. It is guaranteed that at least one possible A exists. That means that they have given the input in such a way that at least one possible A will exist. Okay. So this is like the statement is very mathematical, right? It is very short and precise and mathematical. So let's try to understand it in a diagrammatic way. Like just try to take a feel of it, right? So how do you take a feel of it? Just make some figures and hope for the best. Okay. So yeah, let's first understand that what is this BI? Like this BI is simply f of a1 to I, a2 to I up to ai to I. That is, let's say we have an array 1, 2, 3, 2, 2. Okay. So what is B1? Like I'll use different colors. So B1 is basically f of this, right? Okay. Then what is B2? B2 is basically f of this plus f of this. Like whatever subarray is ending at 2, like I'll just index this as well. Indexing, if I do, then it is 1, 2, 3, 4, 5, right? Or let us do it in zero indexing because the code is in zero indexing. So 0, 1, 2, 3, 4. So your B of 0 is basically f of the subarray A0, right? Then your B of 1 is f of like this subarray plus this subarray. So like f of a0 comma a1 plus f of the array a1. right? And similarly, you can find out that B3 is um, like B3 is this subarray plus this subarray plus this subarray, right? Then B4 would be uh, how to draw it neatly? Let's draw it like this: this plus this plus this plus this, right? And okay, so you get the point, right? Basically, Bi is just the sum of all subarrays, like sum of functions of all subarrays which end at I, right? So that's what Bi means. Now, how can we actually use this array to reconstruct it? Like, okay, first of all, one observation is just that B of 0 would always be 1. Like this f of a of 0, that is the number of distinct elements in this one element array, that's always 1, right? Or basically, f, this is also 1. Basically, f of any array having only one element, it is always 1, right? So B of 0 will always be 1. So in our input, definitely every array will have the first element as 1. Okay, cool. That is one observation. Now, one thing that I want you to think about is that how does the array B change? Okay, like I'll draw this again kind of neatly. So 1, 2, 3, 2, 2. Okay, or 1, 2, 3, 2, 3 कर देते हैं चलो. So I'll draw B2. Okay, so B2 is what? This plus this, right? And what is B3? B3 is basically this plus this plus this. Okay. So now, what is the difference between B2 and B3? Like B2 contains these two subarrays and B3 has these three subarrays. So of course, no subarrays are there common because B3 contains the ones which end at 3 and B2 contains the ones which ends at 2. So there's nothing common. But um, like you can actually try to derive a relation between them. Like B2 has these two and B3 has these three, and actually you can notice that like I'll just number these. Okay, so let's number this um, A1 and this A2, or let's say just 1 and 2, like blue 1, blue 2, and green 1, green 2, and green 3. Okay, so my point is that okay, your B2 is basically f of blue 1 plus f of blue 2, right? And your B3 is equal to f of green 1 plus f of green 2 plus f of green 3, right? And the thing is that f of green 3 is always 1. Like this f of green 3, as you can see, it is only a single element array. So it is always 1. Okay. Okay. Now what you can see is we have a kind of correspondence. Like B2 has f of blue 1 plus f of blue 2, and B3 has f of green 1 and plus f of green 2. And actually you can compare between them. Because what is this blue 1? Blue 1 is the first two elements. And what is green 1? Green 1 is first three elements. So basically there is only one element which is added. It is added, right? So what will change? Like if I try to compare f of blue 1, f of blue 1, and if I try to compare it with f of blue 2, I mean sorry, f of green 1. So the difference between blue 1 and green 1 is that in green 1 there is one more element which is added at the end, right? So what will happen to the value of f? Now what was f? F was basically the number of distinct elements, right, in the array. So the blue one has two distinct elements, and blue 3 has sorry, not blue one has two distinct elements and the green one has three distinct elements. Why is that? Because the element which was added, it it was new. Like it did not coincide with the previous two. Like it is not the same as this one and two. It is a new one, and therefore it will add one to the value of f. That means f of green one is f of blue one, f of blue one plus one. Okay, this is what your observation is. That since this new element has not occurred previously, that's why it will add 1 to the value. And similarly, this f of green 2. F of green 2 is what? 2, comma 3, right? And f of blue 2 was just 2. So as you can see, since in blue 2, this 3 was not there. Therefore, when you include this 3, it becomes a green 2 and f of green 2 is 1 more than f of blue 2. Okay, that's my point. So my point is that when you are including a new element in f, then if it has not occurred previously, then the value of f will increase by 1, and otherwise it will stay the same. That's my point. Okay, guys. So like that is one observation that we have. Like therefore it is not sufficient to solve the problem. The problem is not solved yet, but I have just have one observation like this, and I just told you. So do you guys agree to all of this? Like do you guys get all of this? Just let me know. That the value of f will increase by 1 if we include one more element and that new element has not occurred before, right? And the value of f will stay the same. Yes, it is b. And the value of f will stay the same if the new element has already occurred before in the sub-array. Yeah, so now what we can do? Now let us look at the bigger picture, okay? So I'll give you a better example to explain to you what is happening actually. Like let's say my array A is 1, 2, 3, 4, 2, and 3, okay? And let's say we want to compare our b4 and b5, and basically in one indexing, okay? Like the index starts from 1, 1, 2, 3, 4, 5, 6. Okay, so we want to compare b4 and b5. Like how much will it increase? Can we know? So what does b4 have? Let us try to understand. B4 has this one, this blue one, then this one which is blue 2, then this blue 3, and this blue 4, right? And what does B5 have? B5 have this green one, green 2, green 3, green 4, and green 5. So let's try to compare them. So first of all, this green 5 is just 1, right? That is one observation that we have, that f of green 5 is just equal to 1, because that is a single element, okay? And what we have here is a correspondence between f of 1 1, f of 2 2, f of 3 3, and f of 4 4. Okay, so let's take a look at them one by one. So in each of them, what is happening is at the end 2 is being appended. Like when I have f of blue 1, like I have blue 1 which is 1 2 3 4, and to that I am appending a 2, right? So that is what's happening in blue 1 to green 1. Like this blue one has just 1 2 3 4, and when you are appending a 2, it becomes this green one, right? But since this 1 2 3 4 already has a 2, therefore the value of f of blue one and f of green one is same. So like f of green one will be the same as f of blue one only. it will be the same as f of blue 1. Okay, because this 2 is already there, like the new 2 which is occurring, it's already there in the blue one. So like inserting one more 2 won't change anything, right? It won't change the value of f. Then we have value, like we have this subarray which is blue 2. Blue 2 is 2 3 4, right? And to get green 2 we appended the 2. And again, since this subarray already had 2 in it, therefore including one more 2 won't change the value of f. So f of this green one is still the same as the blue one, right? So basically, due to these f's, the value of b4 doesn't change. Like in b4 we had f of blue 1 plus f of blue 2 plus f of blue 3 plus f of blue 4, right? And in the b5 we have f of green 1 plus f of green 2 plus f of green 3 plus f of green 4 and plus f of green 5 also, but green 5 is just 1, right? So I'll write plus 1. Okay, so now as you can see that f of blue 1 and f of green 1 is same, right? So there is no change because of them, right? So I'll just cancel them out. Okay, then f of blue 2 and green 2 also same, because in the blue 2 array there is already a 2 occurring, so it is the same. Then let's say blue 3. So blue 3 is this one, like blue 3 is this one, right? And green 3 is this longer one. Now since this 2 is not already there in this 3 and 4, therefore it will contribute to one more. Like therefore the value of f3, the value of this green one, will be equal to the value of blue one plus 1, right? Because this 2 is not already there in this 3 and 4. Okay, and similarly for f of 4, this blue 4 is this one, and the green 4 is these two. And since this 2 is not already there in blue 4, therefore its value would be f of blue 4 plus 1, right? So if you see, the difference between b4 and b5 is just of 3. That is, these two are same, right? These two are same. Then this f of green 3 is 1 more than blue 3. And this term is 1 more than this term. And also I have a plus 1 right here. So basically the difference, that is b5 minus b4, that I get is equal to 3, right? So this is the idea, that what is happening actually. And you can extend this to reverse. Like you can actually reverse the logic also. Like here I told you that how do you find out the value of array B from array A, right? If you have the array A, then how do you find out the array B? That's what I told you. But you can reverse this logic and construct the array A also. And how to do that, I'll just generalize. Like first I will generalize this and then I'll tell you. Like, okay, so let's say we have an index I and we know the value of Bi, right? So it will have all of these subarrays, right? And we want to extend this to I plus 1. That is, we want B of I plus 1. So B of I plus 1 will have, it will have these subarrays, right? Okay. So as you can see, this subarray is just 1. Its answer is just 1. And for the remaining subarrays, let's say the value here is k. Okay. So basically all the subarrays, like here there are 4 subarrays, right? So all the subarrays which have k in them, won't change the answer. Like we are including a new element k right here, right? So all of those subarrays which have a k in them will not change the answer. Like their f value will not get changed. So let's say if the last k was right here, then essentially you can see that this subarray already has a k, this subarray already has a k, and this subarray already has a k. Just this one did not have a k, so it will change the answer. Like basically, my answer just depends on the last position. Like when was the last time that we found a k? All right, and that's the entire thing. That if this is the last time that we found a k, then all of the subarrays which start before it already have a k, right? And the subarrays which start after this will not have a k already. So this one subarray doesn't have a k in it, and therefore the answer will increase by 1. Like because of this subarray, the answer will increase by 1. And of course, 1 is by default added, like because of this new 1 length subarray, right? So 1 plus 1, which is 2. So like 2 length subarrays, I mean, like this 2 is added. What I mean to say is that because there is one subarray which is increasing the answer by 1, and also there is this singular one which is always there, the value of b5 is b4 plus 2. Okay, I mean the value of b of I plus 1 is b of I plus 1, sorry, b of I plus 2, right? So essentially my increment only depends on when was the last time that this k was encountered. That is, let's say if I want an increment of 2, then I have to, like, whatever the number is there here, it has to be there here also. Do you get my point, guys? That whatever the number there is at this point, that is at b of I plus 1, it has to be there at b of I plus 1 minus 2 also. Then only it can satisfy. So essentially what we can do is, if we are making the array from left to right, we can simply, like, we can simply copy the value which is at b of I plus 1 minus 2 and shift it to b of I plus 1. Like, I'll explain by example, it will be clearer. So like, let's say you have this 1, 3 and 4. Right, this is your array B. So of course the first would be 1 only. Then B2 minus B1 is 2. That means in your array A, which you had, B1 had only this element, and B2 will have these two subarrays, like these green ones. Okay. So first of all, the answer would increase by 1 because of this, right? Like the answer would increase by 1 because of this, and also since the answer increased by 2, like this 1, 2, 3 ka jump is 2, right? So this subarray also increased the answer by 1. That means that whatever the number there is here, it was not there in this subarray. So that means, let's say if there was a 1 in the A array, this is the A array, okay, the answer array. So I cannot have that 1 right here. So I'll have to have 2 or something, right? That is the logic. Then we go to B3. Like from B2 to B3, the jump is 1. So the jump is 1 means what? It means that, like, in B2 you had this subarray. Um, in B2 you had this subarray, and in, sorry, not just this, you had this one and this one also, and in B3 you have these three subarrays. So of course, because of this, the answer would increase by 1, and because of these two, we don't want the answer to increase, like, because the total increase is 1 only, and that is given by this value. So we don't want that these two subarrays should increase the answer. So that's why we want that whatever number there is right here, which is k, it should be there in this subarray also and in this subarray also. That means whatever number there is right here, that should be the number which is right here. That means if I want the difference of 1, then this b of I should be the same as b of I minus 1. And in general, if I want the difference of d, then my b of I should be equal to my b of I minus b, right? But in case that is too large, like here you can see that this 1, 2, 3 had a gap of 2. So like if I try to apply this formula right here, then we will see that it will underflow. Like 1, 3, and 4 is there, right, in the input. 1, 3, and 4 is there. So if you are trying to construct the array, so like the first element is 1, then the jump is of 2, right? The jump is of 2. So, sorry, here it should be A, not B. My bad. The A of I should be equal to A of I minus B. So the difference is 2, right? So here this is A1, A2, and A3. So here we are saying that A2 should be equal to A of 2 minus difference, right? But which is equal to A0. But as you can see, we have no element which is A0 in our array. That means we need a new element right here. So we will add a new element. So whenever this difference is equal to our index, or like in zero indexing, whenever this I minus d becomes less than 0, we will add a new element right here. And otherwise, we will just copy that element into our position. Like I'll show one more test case, 1, 2, 3, 7. Or let's take a different one, 1, 3, 6. Or 1, 3, 5. Okay. So this is our B array. Alright. So first of all, this is B1, and of course it is 1. So this is B1. And then what is B2? B2 is this plus this. So the answer increases because of this by 1. And we want the increase to be 2. Therefore, the answer should increase due to this one also by 1. So therefore, whatever we have here should not appear in this array. That means if we have a 1 here, we should have a 2 here. Okay. Then what is B3? B3 is basically this plus this plus this. So the answer increases due to, like, the answer increases by 1 due to this array. But we want an increase of 2. We want an increase of 2, right? So we want that um, like whatever number we have here, k, that should be like not equal to, like basically this subarray is giving us 1 increase, right? But we want that this subarray also should give us 1 increase. And this subarray should not give us 1 increase. So what does that mean? That means that whatever k is there, it should not occur in this subarray, but it should have occurred in this subarray. So that means that k has to be equal to this element. So k has to be equal to 1. And therefore you get the answer as 1, 2, 1. And our formula also says the same, that b of I should be equal to b of I minus difference. Like here we had a difference of 2, right? So our b of 3 has to be equal to b of 1, right? And whenever this I minus difference goes out of range, that means we have to add a new value. So we can just maintain a counter that till what elements we have kept in our array, and then we can go further. Okay. So I hope it is clear. Maybe it is not clear to someone. Like I read this comment. Like if it is not clear to you, then I really can't do anything. You can ask some doubts if you have, but I tried my best to explain. Like it is, the problem is very difficult. Like this problem, it is B, but it's, I think, pretty difficult. And all these submissions which are there, I think there must be many must be AI, because it is kind of tough to solve this problem. It should not have been B. But anyways, like whatever I gave the explanation, like I try to give it as much as in depth and with as much intuition as possible. And still if you didn't get, then you can maybe rewatch the video and try to understand it yourself. Like in this, like to understand this problem, you have to think of it by yourself also. Like it, just listening to my explanation will not work. Like you have to think of the statement that I told you by yourself also. Okay. And if you still can't understand, then maybe you can DM me or something. Rating of D. Like it was constructive, right? Like it was not. I mean, it is a hit or miss. I will discuss it when we discuss D. Okay. But for now, let's see the code of B. Okay. Yeah. So I just take the input and I have this answer array and I have this counter. Like I will increment this counter when I want a new element. Okay. So for int I equal to 1, I less than an I plus plus, I'll take the difference. Like I will see that at this point, how much did the value increase. So if I minus difference, like I minus D, if it is in my bounds, then my answer of I would be answer of I minus D, right? Otherwise, I need a new element. So answer of I would be plus plus count. And I just print the answer of, like, finally just print the array. That is the logic. Like basically, the final answer is pretty simple. That your b of I is b of, sorry, not b of I, a of I. A of I is a of I minus d. If I minus d is in bounds, if I minus d is greater than or equal to 0, otherwise a of I is a new element. And since you want all the elements to be between 1 to n, you can, like, just maintain a counter which gets incremented every time you want a new element. So of course it will always remain less than or equal to n. Okay. So anyways, this was the problem. It might not be very clear to all of you, so you can comment on this video. Okay, and I will try to answer my best. What was my rank? Let's not go to let's not do discuss that. Like underperformed only, I guess. 396 in Div 2, which is not that good according to my level, I think. But yeah. Anyways, let's solve C now. Reverse OR. Actually, C was much easier than B. Like I felt that. Given a positive integer x, let f of x be the positive integer formed by reversing the binary representation of x without leading zeros. For example, if x is equal to 12, then it is 1100. Then if x is 0011, which is 3. You are given an integer n. Determine if there exists a positive integer x such that x XOR fx is equal to n. So what they are just saying is that we have a binary number x, okay, and fx is just the reverse of x. That means if you write x in binary and then you reverse it, then that is f of x. And what we want is, we want x XOR fx should be equal to n. That means they have given us an input n, and we have to print if there is an x such that x XOR fx is equal to n. That is the problem. Okay. So it is a pretty nice problem actually. because you might think of some assumptions and they will be wrong. Like here, I just first saw that the answer for 6 is yes, and then I try to prove it why it is yes. Like they are saying that if n is equal to 6, then we can find such an x such that x XOR fx is equal to 6, right? So how can we find? Like I try to find out an x. Okay, so I wrote 6 in binary, 110, right? So at this point, I wrongly assume that since this number is 3 digit, therefore my x all has to be three digits. Like I just assume that, and I tried all 3 digit combinations. Like I tried 100, so it reverses 001 and it gives 101. So which is not correct. Then I tried 101, it reverses 101 and it gives 0, which is not 6. Then I tried 110, reverses 011 and it gives 101, also not correct. And finally I tried 111, reverses 111 and it gives 0, which is also not correct. So I could not get a 6, basically. Like I could not find an x such that x XOR fx is 6. So I thought to myself that what is this? Is the answer wrong? But then I realized that you can have, like x can have more bits also. Like the entire catch of this problem is that x can contain more number of bits, um, and finally it might be zeroed out. Like basically here the value of x is what? Anyone in the chat? Can you guys tell me that what is the value of x? Did you find out? 13. Okay, so 13 is what? 1101, right? So if you reverse it, it becomes 1011. So if we take a XOR, it is 0110 exactly. So as you can see that this number has become 0110. So x is equal to 13 works for this, right? Now, what was the flaw in my logic? Like here, I assume that the like since 6 is 3 digit, therefore x also should be 3 digits. Otherwise, I won't get a 3 digit number. But actually, what happened was when I reversed this number, like when I reversed this number and I took the XOR, this MSB, like this bit actually turned out to be 0. And therefore, this 4 digit number actually became a 3 digit number. Okay. So that also might happen. Like it might happen that when you do X XOR fx, X XOR fx, you might not get exactly n. Like if you write n in the binary without any leading zeros, you might not get that directly. It might also happen that you get some more zeros as well in the starting. Okay. So what you can do is just try to check for all of them. Like just try to check for all the possibilities. Like that's what I did. What I did was I assumed that okay, let's say we want to check for n equals to 6. So n equal to 6 is 110, right? So I first try that can I make 110? Like can I have two 3 digit numbers whose XOR is 110? I first tried that. So I failed. Then I tried adding 10 here. So I tried that can I make 0110 using two 4 digit numbers? So is it possible? And in that case, I said yes, it is possible, and therefore I passed. Right. So you can simply try to add some leading zeros and just check that is it possible to make. But how do you actually check it? Like let's say you added some zeros and you want to check now that can you make this number or not using these 7 digit, let's say. Like if we have a 7 digits right here, you want to make it using two 7 digit numbers, then how do you check if it is possible or not? So let's try to understand that. Okay. So let's say we have this number n. and in its binary, it is, let's say, a 5-digit number: y1, y2, y3, y4, y5. Okay. So we have 5 digits. That means x also has to be 5 digits, because there might be leading zeros. Like if x is not 5 digits, if it is more, then that will handle in the next iteration. Like currently we are dealing with only 5-digit numbers. Okay. So it has to be 5 digits: x1, x2, x3, x4, x5. Like this is x in binary form, where x1, x2, x3, x4, x5 are all either 0 or 1. That means it can be something like 0, 1, 1, 0, 1. So x1 is 0, x2 is 1, x3 is 1, x4 is 0, x5 is 1. So I'm writing x in binary as these 5 digits, right? And what's the reverse? Reverse is x5, x4, x3, x2, and x1, right? So this is f of x. And now what I want that basically this should be same. Like basically these two का XOR should be equal to this, right? So what does that mean? That means that x1 XOR x5 should be equal to y1, x2 XOR x4 should be equal to y2, then x3 XOR x3 should be equal to y3, then x4 XOR x2, which is this one only, should be equal to y4, and x5 XOR x1, that is this, should be equal to y5. So you can see that this is my condition, that x1 XOR x5 should be equal to y1 and y5 also. Then x2 XOR x4 should be equal to y2 and y4 also. And x3 XOR x3 should be equal to y3. And also x3 XOR x3 is what? x3 XOR x3 is basically 0, right? Okay. So that means that, and yeah, also one more condition, that x1 should be 1, because we should not have any leading zeros in our x, right? Otherwise, if you reverse it, x1 cannot come here. Like you cannot say that x is 0 1 1 0 1 and its reverse is 1 0 1 1 0. This is not allowed, because the reverse of this would just be 1 0 1 1. Like this 0 cannot be here. All right. So x1 should not be equal to 0, but that is fine. What we want is x1 or x5 should be equal to y1 and y5. x2 or x4 should be equal to y2 and y4, and x3 or x3, that is 0, should be equal to y3. That means y3 should be equal to 0, y2 and y4 should be equal to, like, should be equal, and y1 and y5 should be also equal. So that is our condition. Like if we have this satisfied, then of course we can find the value of x. Like we can simply put anything. Like x1 has to be 1, but otherwise x5. Like if y1 is 1, then we put x5 as 0, and if y1 is 0, we put x5 as 1. Then x2 or x4, if these two are 1, then we can either put it 1 0 or 0 1 also, doesn't matter. And if y2 is, like, if these two are 0, then we can put them as 0 0 or 1 1. So basically this is a condition only. This is the condition for which it will exist or not. Like if we have this 5-digit number and we want to check that does there exist any x for which x XOR fx is this number, then this is the condition, that y1 should be equal to y5, y2 should be equal to y4, and y3 should be equal to 0. So if we have any number like this, then we can say that x exists, right? So this was for odd number, like this was for odd length, right? y1 and y5, like length equals to 5. But what if we have even length, like let's say 4, y1, y2, y3, and y4? So in that case also we'll have a similar thing, except this middle element is not there. Like we don't have a middle element, right? So this x3 or x3 doesn't happen. So we don't have a condition that it should be 0. Like I'll show you here. x1, x2, x3, x4, and the reverse is x4, x3, x2, and x1. So if you take the XOR of these two, y1 should be equal to x1 XOR x4, which should also be equal to x4 or, like, this is also equal to y4, right? Because y4 is also equal to x4 or x1. Then y2 should be equal to x2 XOR x3, This should also be equal to y3. So basically, my point is that y1 should be equal to y4 and y2 should be equal to y3. That is the condition. So finally, the condition becomes that the string should be a palindrome. Like these two should be equal and these should be equal. And also if the string length is odd, if the string length is odd, then the middle element should be equal to 0. Right? That is the condition. So at this point, you can simply check. Like now, your problem is what? You have been given an n, right? You have been given an n, and you want to check that is it possible for me to find an x. So let's say n equals to 6 is given. We have 110, right? So is this 110 possible? Like, can you find a three-digit number whose reverse and its XOR is 110? No, you can't, right? Because it is not a palindrome. Like these two are not the same, so we cannot find it. Now let us try to append 10 right here. So now is it possible? Yes, it is possible because this 00 are same and this 11 are same, and the length is even. So there is no middle element like this, right? So the answer for this is yes. And now let's say we have one more test case, 11. So for 11, the answer is no. Why is it no? Because let's say 11 is 1011, right? So for this one, it is not possible because it is not palindrome. These two are not same. Then let's say we append 10 right here. So even now, it is not a palindrome, so it is not correct. Then we append one more 0. It is still not a palindrome. Append one more 0, still not a palindrome. So like you can append zeros, and actually you need to append zeros at most 30 times only, because we know that the input digits, like the input is at max 2 to the power 30 minus 1. That means the input will have at most 30 binary digits. So of course, appending more than 30 zeros will not gain anything. Like agar 30 like if you have already appended 30 zeros and still it is not a palindrome, then of course even after that it can't become a palindrome. So what you just need to do is try to append 30 zeros, and each time just check that is it possible or not. Like one more example, if I take 3, or 3 is simple. Like 3 is what? 3 is 1 1, and it is a palindrome already, so it is satisfied. Um, then let's say we have 10. Okay, 10 is a good one, I guess. 1010. So like this is not possible because it is not a palindrome. But if we append a 0 right here, now it is possible because this is equal to this is equal to this, and the middle one is 0. Okay, so this is possible, and therefore the answer for 10 is yes. Okay, so this is the solution. Like you can just brute force it, just append 30 times and just check it every time. And if any one of them is 1, like any one of the answers is yes, then the answer is yes, otherwise the answer is no. Right? Okay, thank you. All right. So let us move on. Okay, like any doubts, anyone? Just let me know. Fest is going on at IIT Dhanbad. Got confused after solving for 10. No problem. Um, like I hope you get it now. I hope you got it now. Okay, thank you very much. So all right, I'll show the code now. Okay. Okay, let's try again VPN. Yeah. So I have this function, which is check function, which is just checking that like this condition that I have here. that in my y, it should be a palindrome first of all, and if its length is odd, then the middle one has to be 0. So I have this function which just checks that condition. So like I just iterate over this string, like I just take in the binary string and just check if it is a palindrome. So for int I equal to 0, I less than n, I plus plus. If s of I is not equal to s of n minus 1 minus I, that means it is not a palindrome. So I'll just return false right there. And if s dot size is odd, then the middle one has to be equal to 1. I mean, has to be equal to 0, right? So if it is 1, then I return false. And if I did not return false right here, then it is true. So like it is satisfied, so it is true. All right. And this function just converts the integer to binary. And I think you all must know how it is done. And if you don't, then you can just Google it. It is no issues. So in the solve function, I have int n, c in n. I will convert this n into the string, and then I check if that original string is valid or not. If it is, then I'll print yes and I'll return. And then I will append the 0 30 times, or like for safety, I just did 35 times, but I think 30 is enough. Okay. So each time I just append a 0, I just append new 0, a leading 0, and check if it is valid. And if it is, then I'll print yes and return immediately. And after 35 iterations, if I still haven't got it, I still haven't got the condition, then I'll print no. Okay. So this was the code. Thank you, Bhavit. Yeah. Now let's come to the main problem, which is D. Actually, D solution is pretty hit or miss kind of thing. Like, anyways, let's discuss that. I hope there are no doubts. Finally, yeah. Well, if you guys just wanted the solution for D, then you could have joined like 1 hour late or something. But anyways, or you can watch the recording also. Anyways, the D problem was you have a secret sequence A1 to A2n, which contains each integer from 0 to 1, 0 to, which contains each integer from 1 to n exactly twice. So like there are 2n numbers, and this has each integer from 1 to n twice. Okay. Your task is to guess the sequence by using the following queries. So you can select an integer k and k distinct indices j1, j2 up to jk. In response to the query, the jury will return mad of aj1, aj2 up to ajk, where mad is defined as the largest integer which appears at least twice. Specifically, if there is no number that appears at least twice, then mad is 0. Like for example, the mad of 1 to 1 is 1 because this 1 appears twice, and that is the maximum that appears twice. Then this mad of 2 2 3 3 is 3 because here both 2 and 3 appear twice, but 3 is the bigger one. And mad of 1 2 3 4 is 0 because this sequence has no numbers which appear twice, right? So it will return 0. So what we can do is, like in a single query, we can ask the jury that in this subsequence, like we can give it a set of indices, and it will return that what is the mad of that, right? So for example, we have this input 2211. Like if this was the array, which is 2211, and like we ask the query, let's say like this is the index 1 2 3 and 4. So this is the index, and if I ask the query that okay, give me the answer for 1 comma 3, that is these two indices. So what is the corresponding array? The array is 2 1, right? So the mad of 2 1 is 0. The mad of 2 1 is 0. All right. So I'll get 0 as my return value, right, from the input, from the jury, right? And if I ask, let's say 1 2 3, then 1 2 3 corresponding array is what? 2 2 1, right? and the MAD of this is 2. So we can determine that there is 2 at least twice out of these 3 indices, right? So that's what we can do as a query. And we have to find out that what is the array in at most 3n queries. Okay. So one thing that I noticed, like, okay, I'll just, since there is no like certain intuition, like if the logic gets you, then it gets you. Otherwise, it doesn't. So that's why I'll just tell my thought process. Although I don't think if it, I don't know if it is of much help, but I'll still tell you. So first of all, I thought of like I think binary search. Like what I did is that okay, we have 2n length array, right? Let's say n is equal to 4. So we have 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. So what I thought was, first of all, obviously, if you query the entire array, like if you input, I mean, if you output 1 to 8, all the numbers, then what will you get? Like, it will be obvious, right? Whatever the array is, if you just output all of the numbers, then what will you get as the answer? Yes, exactly. 4, yes. Because all of the numbers will appear twice in the array, right? And the maximum one will be 4, correct? So you will get that. But what if you like query only the first half? So basically, my point is, if you query the entire thing, you will get 4 always. But if you query only the first half, then you will get a 4 only if this has 2 fours. Like if you get a number which is not 4, that will mean that your second 4, like, okay, there are 2 fours, right? There's a left one and there's a right one. Like the left one is here, let's say, and the right one is here. Then if you query like this, there is only one 4 is there, then you will get non 4 answer, right? And if you query like this, that is both 4s are there, then you will get like an answer as 4, right? So using that, like you can simply do a binary search for the right 4. That means, like let's say you query like this, so you get a non 4 answer, right? So you will know that the right 4 will lie in this region, right? So then you will query like this 1 to 6. So now you will get a 4 answer. Therefore, you will know that the right 4 lies in this region. And now you will query like this. So you will know, like you will get a non 4 answer. So you will know that your right 4 is here. So like this is kind of binary search approach by which you can find out the position of the right 4 by using queries of type 1 comma I. Like you can query like this and like this. Like if you query 1 comma I, like all the indices between 1 and I, and if you get a 4 answer, then that means the writer 4 is at position less than equal to I. And if you query 1 comma I and you get a non 4, then that means that your writer 4 is at a position greater than I. So you can simply do a binary search for the writer 4 position. So this was one of the methods that I came up with. And like as so you by this method you will know the position of the writer 4. And similarly, if you want the lefter 4, what you can do is just do a binary search in the reverse order. Like you made queries like this, right, to find the writer 4, you like this. But now you can query like this. If you want to find the left one, you can query like this. Like if you do like this and you get non 4 answer, so you will know that the leftmost 4 is on the left half. Then you will query this, so you still get a non 4 answer. So you will know that you will get your 4 in the left half. Then you will query like this and you got your 4 right here, so you will know the position of the 4, right? But this is problematic because it will take up too many queries. Okay, because for each element I am taking log n amount of queries, right? And not even log n, log 2n, right? Because the array length is 2n. So um, this won't work. Okay. So this was one of the thought process that like I did. Okay. But the actual solution is not like this. We can do it in even less number of queries. Okay. Even less than n log 2n. Like this will take 2n log 2n, right? But that is too much because we have only 3n queries. So actually what we can do is I'll show you an example. Okay. So let's say my array is 1, 2, 3, 1, 2, 4, 4, 3. Okay. This was my hidden array. Alright. So let's play a game now. Let's say I just query this first element. Okay. Then let's say, okay, so what will I get the answer? I'll get 0 as the answer because there are no duplicates in this array. Right. Now let's say I extend this and I query 2. So again I'll get 0 as the answer. Right. Now let's say I extend this once more and I get, like I extend this once more to 3. And also again I get the array 0. I mean I get the answer as 0. Right. Now I extend this once more. Now there is a duplicate. Right. And we get an answer as 1. Right. So what can we say? What can we say? Can't we say that this should be a 1? Like even if you didn't know that this is the array, you saw that this subarray was giving the answer 0. And as soon as you took this also into account, it gave the answer as 1. That means we have a duplicate which is 1. And that was there only after we included this. So therefore we will know that here is a 1. Okay guys, is this clear? So we got a 1 right here. So like, okay, I increased it to this and we got a 1. Alright. So we know that this is a 1. So I'll mark it green. That means I have figured this out using my queries. Now what will I do is, I will not include this one into my query. Like currently I have all of these 4, right? Like in my last query, I asked all these 4 numbers in my query. But now what I'll do is, I will not ask these 4. Like I will not ask this one, okay? And there's a reason for that. I will not ask this. Okay. So let's say I don't ask this, and like I just ask these 3. This one, this one, this one. And now I ask the next number. Like I ask this one also. So now what will I get as the answer? I will get a 2. I get a 2. Right. And since I knew that this answer was 0, and by including this number I got a 2, therefore this must be a 2. Right. And now again, I will not include this in my array. Like I am basically trying to ensure that except for the last number, all the other numbers should not be duplicates. Taki, like, so that if I get a duplicate, like if this new number is a duplicate, then I will know its value. Like see, currently I have these 3. I did not include this. Then I query for this one. Like I will include this also. So now I have these 4 numbers, these 3 and this one, and I'll query for that. So I will get 0, right? I will get 0. So I'll know that this number is not duplicate. So these 4 numbers are not duplicate. So I will keep this in my query. Now I will query this once more. Okay. And now I'll know that I got the answer 4. So since we knew that these 4 numbers had no duplicates, but when I included this one also, this new one, now I have a 4. 4 is the duplicate. That means that this number must be a 4, right? And also now I won't include this in my query, because I want to ensure that there are no duplicates in my query. So I will exclude this. So currently I have these four, and now lastly I will include this one also. And you can see that these four had no duplicates, but this fifth one, when I included, it's a duplicate, which is 3, and therefore I will get the answer 3, and I will know that this is a 3, right? So by just doing this, I can simply find the positions of the right occurrences. Like every number will have two occurrences, right? A left one and a right one. And if I do this, like just start with the first element, then the first two, then first three, and as soon as we get a duplicate, we won't include that. So if we just do this process, we will find out the positions of all the right occurrences, right? And like, why did I exclude this one right here? Like, let's just get an intuition for that. Like, let's say I had this array. Let's say I had n equals to 3, and I have this array, uh, 2, 1, 2, 1, 3, 3. Right. So first I'll query this, so I'll get 0. Then I will query this, so I'll still get 0. That means I have no duplicates here. Then I will query this, so I got a 2. That means I know that there's a 2 right here. Now let's say if I did not exclude this index, like let's say I again queried, like I again continued the process and queried for these four numbers. Okay, I queried for these four numbers. Then what will I get? I will actually get a 2 only, and that doesn't give me anything, because I already knew that the 2 was a duplicate in my array, and since this 1 is smaller than 2, I don't get any new information. Therefore I ensure that there are no duplicates in my array. There are no duplicates in my array. So I will remove this index and query only these three. So now if this one is repeated, like if this is the right occurrence of this one, it will definitely be my answer. So in my answer this query, I'll get a 1, and I'll know that there's a 1 right here. And also I'll remove it from my query, right? So now I will query for 3 also, and so these three elements, it will give me the answer 0, because this is the left 3, right? And when I include this also, I will get the answer 3, and therefore I know that this is the element 3. So this is how we will get the position of all the right elements, right? So do you guys get this part? Okay. Uh, no, Chirag, it doesn't. It just fix some. I mean, you can do it. Actually, you cannot even use that segmenter because it will give TLE. Um, yeah, and after finding out all right occurrences, we'll query it with each left occurrences. Yes. So, like, okay, while doing this process, you actually did 2n queries, right? Like, first you did this query, then you did this, then you did this, then you did this. So basically, the length of this array is 2n, right? So you are already done with 2n queries. And after this 2n queries, um, you have you have found out all the right occurrences of the elements. Like in this array, out of these two ones, you have found the right one, but you still don't know that where is the left one. So now what will you do? So as MacDon said, we will find out the left ones also. We'll query with each left occurrences. But so like I think what he is saying is that we can do this process in reverse. Like whatever we did going forward, we can just do it in reverse. So we'll find the left occurrences. But some of you might think that it will again take 2n more queries. Like when we are going ahead, it took 2n queries, right? So when we do the same thing in reverse, it will take 2n more queries. So it will be 4n queries, right? And that is not ideal, like because our limit is 3n, right? So how will it do? Like how will we do that? If we have only 3n queries, but doing in reverse again will give 4n queries. So what do we do? Yeah, that is correct. Like we'll only include the ones which are already found. Like basically, the entire catch is that okay, while going forward, we took two n queries. That was because we did not know anything about these. Like let's say when I queried this, then I queried this, then I queried this. Now I had to query this also because it was possible that there might be a right occurrence of some number on this index, right? So I have to query this. But let's say while going in reverse, like uh, let's say I have this array, like I know that the right occurrence of 1 is right here, um, of 2 is right here, 3 is right here, and 4 is right here. Okay, like let's say I already know this from my first iteration, like from my first two n queries, I know these positions. So while doing it in reverse, what will I do? While doing it in reverse, I will actually like I will not query for this because I already know that what is the number here. Like I will simply include it in my query, but I already know right, that this is not something that I don't know. Like my point is that I know already this, right? So I won't query for this array. What I directly do is query for these two, right? And let's say I got a 4 right here. So I will know that since this part did not have any duplicates, so this must be a 4, right? Now I will not include this in like I will not include this index into my query. I will only include these two, like only this one. I mean, I'll include this one only. Then I go here and I include this one, but I don't query for these two. I don't query for these because I know that both of these, like I know both of these, right? So uh, there is no point in querying. Now I'll go here and I will query for this because I do not know this index. So the point is that I will only query for those indices which I don't know already. And there are n of them. There are n such indices which I don't know. And so I will simply do n queries. Or actually, one more, there is one easier method also. Like I did like this that while going in reverse, but skipping those numbers which I already know. Instead of doing this, you can simply do what? Like you can simply, like let's say, um, you have these right. You have these positions. So just always query these. Just query these four, and one by one, just query for this. Like you have these four numbers, and just include one more which you don't know. So of course, whatever is here, it will be paired up with one of these, and it will be the answer for that query. And again, then you will remove this, and you will ask for this. So you will know the answer for this. And similarly, you will query for this, you will query for this, and it is solved. So in n more queries, you have solved this. So it is 3n queries. And I think that is what MacDon was saying. All right. And yeah, that was probably what Ronnie was saying also. And yeah, you both are correct. Very nice. Yeah, cool. So this is the solution. Stuck in B. Yeah, same here, brother. Like normally I would not take this much time in B. I took like 15 minutes. I mean, okay, that is still not that much, but B was pretty tough for its position. I agree. But yeah, so this is what the querying looked like. Do you guys get it? Just let me know. Yeah, it is. I mean, I am kind of out of practice lately due to some reasons. So, like, of course, I should practice more. That is true. But yeah, maybe skill issue थोड़ा कम हो जाएगा. Anyways, all right. So I'll show the code now. So the code is for D, right? Uh, okay. Why is this code forces so bad? Anyways, I have this function like just to print the query so that I don't have any printing bugs. Like I don't have to write all of this code again and again if I want to query. So I just made a function that it will take in the vector of indices which I want to query and it will print in the given format and it will return the actual answer. Okay. So in my code, LLN, CNN, and I have made this vector of 2n length, which is my answer vector, which I will print finally. And I have this query vector, and query vector contains that currently what is the like basically what will I pass into this function that is my query vector, and initially it contains only the index 0, right? Then I start from index 1 to 2n, and I'll push back I. That means I include this I, and I query for it. So if it is non-zero, that means the ith index is a duplicate, like it is a right occurrence of something. So the ans of I would be just an, and I will remove that element from the last. Like I will not include that. I'll not include I from in my further queries because I know that it is duplicate, and I don't want any duplicates in my array. Right. So this will take like 2n-1 queries. Okay, and it will find all the right occurrences in my ans array, and other elements would be 0. Then I just clear this query, and yeah, I just do what I said. I just push back the last element, and I start iterating from reverse. I equals to 2n minus 2, I greater than equal to 0, I minus minus, and I push back I. If I already know the answer, if answer of I is not equal to 0, then I continue. That means I don't query for this, and also I keep that index in my array. And otherwise I do the query. And of course, like if I did not know this current index, then definitely it is duplicate, like it is the left occurrence, right? And since I already have the right occurrences in my query array, it will give me a non-zero answer, and I will set answer phi equals to an. Actually, this is complicated unnecessarily. You can simply do what Suhani said, but yeah, and simply query dot popback. Like popback, I'm doing when it is the left occurrence, right? So, anyways, we'll just finally print the answer, right? So that was B. Okay. I hope it is clear to all. Still, I got 396. Well, actually, it is not really 396 because it is in division 2. Like today, it was both div 1 and div 2. So the CMs were not there in the rank list. So in actual reality, my rank would have been like 1000 or something. But anyways, all right. So let us discuss problem E now. Like let us try to finish this quickly. Although problem E is pretty tough, like even I couldn't solve it. Like I have solved it, but I haven't written the code yet, so I can't show you the code now. But I will tell you the logic. Okay, and it is just computation. Okay, like there's no particular logic here. It's just kind of brute force thing. Okay, there is one observation that you have to do, and then it is not very easy, but you get the idea. Okay. So the problem is you are given a binary grid G of dimensions n by n. Let us define a rectangle as tuple UDLR that satisfies the following conditions. U is less than D and they are between 1 and m. L is less than R and they are between 1 and m. And the cells U, L, U, R, D, L and D, R all contain a 1. That means basically you have a rectangle like this. Uh, let's say this is your rectangle. Okay. Like I hope you can see it on screen share. So this is your rectangle. And basically the constraint is that all of the corners of the rectangle should have a 1. Like so this one, this one, this one, this one, this one, and this one, they are all ones. So this is a valid rectangle. And also the rectangle cannot have a dimension of 1. Like u less than d is compulsory, and also l less than r is compulsory. The rectangle has to have both sides at least 2, right? And the area is defined as simply the area, that is d minus u plus 1 into r minus l plus 1. That is the number of elements in that region, right? So here you may see two rectangles, 1, 2, 1, 3. 1, 2, 1, 3 means that the u is 1, like the row 1, row 2, and column 1, column 3. So basically these four cells that I showed you, this one, this one, this one, and this one. And 1, 3, 3, 5. Like first row, third row, first column, sorry, third column, fifth column. So this one, this one, this one, and this one. So these two are rectangles. Okay. And the area is 6 and 9. For each cell ij, find the minimum area of a rectangle UDLR such that I is between U and D and J is between L and R. Okay. So essentially what they are trying to say is that we have to find for every cell, like we have been given this binary array or binary matrix, right? Let's take a sample input. Let's just take this one only, 10101, 10100, 001, 01. Okay. So what you can do is, like what you have to do is for every cell, let's say for this cell, you have to print the minimum area of a rectangle which contains this cell, right? So basically here we have two cells, we have two rectangles, right? One is this rectangle right here, and one more is this one right here. Like in this entire grid, we have only two rectangles, and so this cell is contained in this rectangle, right? And therefore the minimum area for this cell would be 6. So the answer is 6 for this. Like I'll draw a new matrix for the answer. So the answer is 6. Then for this one, it is not there in any rectangle, right? So I have to print 0. Like output 0 if no rectangles contain that cell. So the answer is 0 for this, 0 for this. And then for this cell, like this cell is contained in both this rectangle and this rectangle, but this area is less. This area is 6 and this area is 9. So the answer is 6. And similarly, I'll just fill the entire matrix for you. 9, 9, 9, 9, and 9, 9, 9. Okay. So like I think it should be pretty clear. If you are solving this problem, then this should be pretty clear. Okay. So that's what we have to do. And the constraints here are that n and m are not bounded, but this n into m is given to be less than 2.5 into 10 to the power 5. Like there is no constraint on n and m individually, but your n into m, the product is less than equal to 2 into 10 to the power or 2.5, or let's say 25 into 10 power 4. So like they could have given us that n is less than equal to 500 and m is less than equal to 500, but they did not. They gave us that product is less than 25 into 10 to the power 4. So what does that mean? That it means that n can be 2 into 2.5 into 10 to the power 4, and m can be equal to 1. This is also possible in the input. Okay, but if they had given this, then it would not be possible. So, but anyways, now one thing that it is very common, like this is actually a pattern that we can use in many problems like this, that we can solve it in nm square. Like actually, See, if it was given that n is less than equal to 500 and m is less than equal to 500, then I think you could see that we can solve it in O of n square m or nm square, let's say. So I'll square, let's say we solve it in O of n square m. So that is possible. Okay. Because n is less than 500 and m is less than 500. So n square m will be approximately 10 to the power 8 only. Okay. 10 to the power 8 into 1.25 or something. Right. So this would pass because the time limit is also 4 seconds. It is pretty high. Right. But here they have given us that n into m is less than 2.5 into 10 to the power 5. So now if we do n square m, then it might give TLE if this n is too large. If this n is too large, then it might give TLE. But doing it in O of n into m is not possible. Like actually, I cannot solve it in O of n into m. If you can, then it is nice for you. But I cannot solve it in O of n into m. So what do we do now? Like we cannot solve it in O of n square m because n can be this, but uh, it is not possible in n into n. So now what do we do, guys? Any ideas? It's 2300. Yeah, it might be. Like it is a nice problem actually. Change dimension on n is really big. Yes, exactly. Rupam Pradeep, you are correct. Neeraj, yeah, exactly. So what do we do when we get an input like this? We just assume that this is n and this is m. That means we can simply transpose the matrix, like whatever is the input that we have been given. That is A, which is of size n by m. We will just take a transpose of it. We will just take transpose of it and make it size m by m. And then we find the answer for that in O of n square m. And we will again transpose the answer and print it finally. That is an entire approach. So we can do it in O of n square m. Like basically we can essentially what we are doing is we are solving it in, like we are keeping n as the minimum one. So we are essentially solving it in O of n into m into minimum of nm, right? And we know that n into m is constrained to be 2 into like or 2.5 into 10 to the power 5, right? And the minimum of nm is what? In the worst case, even when n and m are equal, okay. In the best case, what it is? Best case is that let's say n equals to 1 and m equals to 2e5. Sorry, I think it's 10 to the power. Yeah, okay, 2.5 e5, right? So in the best case, this can be it. So in that case, we'll get 1. But what if they are both approximately equal? Like what if n equals to 1 and m, like sorry, what if n is equal to 500 and m is equal to 500? Then it will be 2.5 into 10 to the power 5 into 500. So this will also pass. This is also like 1.25 into 10 to the power 8. So this will pass. So we can solve it in O of n into m into min of nm, or simply like O of n square m. O of n square m if we assume that n is less than m. And if n is not less than m, we can just take the transpose of the matrix and we can solve it in O of n square m. So that's the intended approach of this, like O of n square m. But how do we solve it in O of n square m? That is the question. Okay. So let us try to understand how to solve it in n square m. Okay. So let's say we have a matrix. We have this matrix and we have some ones and zeros in this, and we want to um, find out that what is the answer for each. So basically what is it? The thing is that we can have a rectangle only if all of its four corners are 1. All its four corners are 1, then only we can have a rectangle, right? So that rectangle can be the answer for all its interior cells, right? So what can we do? And first of all, we want to find the minimum area rectangle, right? We want to find a rectangle with minimum area, right? So what we can do is we can try to exploit that we have n square m as possible. Like we can solve it in n square m. So we can exploit that. Okay. So like if I remind you that this dimension is n. Let me just turn off the grid for once. Can I do it? That is the question. Uh, Maybe I can't. I mean, I probably can, but I don't know how to. Anyways, um, yeah. So okay, let's write like this. So we have this grid right here. This is the input, right? And this is n, and this is n. And what we can do is we can solve it in n square m. That is allowed, right? So actually, what I try to do is I try to, like, let's say this is the um, rectangle, right? So it will start at some, like, row 1, which is I, and at row 2, which is j, and it has some columns also. So let's say this is c1 and c2, right? So what I did was I iterated over I and j. Like I just made an n square for loop. So for I, like for I equals to 0 to n minus 1, and for j equals to I plus 1 to n minus 1, because j has to be greater than I, right? J greater than I. So I just iterated in this n square for loop, and I just checked all the rectangles. Like okay, then what I did, I just like for those two rows that I selected, like let's say I had this grid and I'm iterating over I and j, and let's say currently I am at these two rows. Like this is one row, the row I, and this is another row, the row j, right? So what I did was, okay, if you want a rectangle to be like this, like let's say you want a rectangle like this, that means you have to have a 1 at all of these four positions, right? And also one more thing is that let's say you have multiple ones, like let's say you have one here, here also, then here also, here also, then here also, here also, and here also, here also. Okay, and like they are in same column, right? Like that's what I want to draw, that these two are in same column, these two and these two are same column. And like let's say you have a 0 0 here, 1 here, then this one doesn't matter because you cannot take a 0 as a corner of the rectangle, right? So you cannot take this column as your rectangle, so let's ignore that for now. But let's say you have these four pairs of ones, right? So my point is that in your optimal answers, um, this does not matter. Like this rectangle, it is valid, but it does not matter. Why? Because you want the rectangle with the minimum area, right? So you will never take this rectangle because for all of these cells which are in this region, you can always take either this one or you can take this one, and both of these definitely have area less than this one. So you will never take this bigger rectangle. So my point is that you can always just take a look at the adjacent pairs of ones. Like this is one pair and this is another pair, and they're adjacent. So you can just look at these ones only. And adjacent, say I mean इनके बीच में कोई भी पेयर ऑफ वंस नहीं है. Like either there is a two zeros or a single zero or a single one. There is no one one in between. And if there's a one one in between, you will not take a look at this. Okay. All right. So so basically you can iterate. Like see, you have fixed I, you have fixed j. So usme you have n square loop already, right? Now you can simply have two pointers like this, like from left to right. Um, you can just check for adjacent pairs of ones, right? And that will take you O of m loop extra, right? Like let's say you have these four ones. So first you will check this one, then two, and then three. So in the worst case, you will have to check O of m rectangles, right? Okay. So until here, is it clear, guys? That you can simply iterate over all rectangles in O of n square into m. Like in O of n square into m, you can iterate over all rectangles, right? So could it, do you get this part? All right. So now, if you, let's say you iterated over all the rectangles, and let's say that you have something like magic, like basically you have, let's say, a structure, a data structure, which will update. Like let's say initially, like you have a table, okay, you have a table filled with numbers, infinity. Like let's say initially, this has numbers, and initially they're all infinity, okay. And like okay, you get the point. They're all infinity initially. And let's say that this data structure allows you to update, like what it allows you is that you can specify four indices. That means you can specify a rectangle in this grid, and you can specify a value k. And what will the structure do? It will take the minimum, like for every cell ij, like for every cell aij, it will take the minimum of aij and k, and it can do it in O of 1 per query. Like basically, for every cell in this region that you specify, it will take the minimum with k, and you can give that k as well, and it can do it in O of 1. So if there is such a data structure, then can you say that the problem is solved? Can't you say that the problem is solved? Right? Because what you can simply do is you can simply iterate all rectangles. Like let's say you fix this I, you fix this j, and then let's say like you have now you are iterating over adjacent pairs of ones. So let's say you have this one rectangle. So its area is what? Like you can find its area, right? And for all of these cells which are in this region, this is one of the possibilities. Like this rectangle is one possible rectangle. So what you can simply do is maintain an answer vector and like maintain an answer grid and take the minimum for all of these cells. Like in this data structure, thus like just give it this region, just give it this region and this area of the rectangle and take the minimum. Like just tell the structure to take the minimum for all of these cells, right? And if you do this for all rectangles, then finally, of course, what you will end up with is the minimum in each cell for all the rectangles, right? This DS basically, like, let's say you have a matrix, you have a grid of numbers, and what you can tell this DS to do is like what you can tell this DS is you can give it a range. Like you can give it a rectangle, okay, and you can give it a value k. And for all cells aij, for all cells aij in this rectangle, it will perform aij is equal to min of aij comma k. That means if initially this cell is lower than k, then it will stay the same. And if it was more than k, then it will become k. So this magical data structure performs this operation. Okay. So then is the problem solved if it can do it in O of 1? Do you get it, guys? Yes, Pradeep. Okay. All right. So, but actually, this doesn't exist. Like this kind of DS actually does not really exist, and I was just giving you false hopes. But actually, the idea is pretty similar. Like all we want to do now is basically do a range update. Like on this answer matrix, we basically want to do a range update and just take the minimum for all the cells, right? But how do we do that? That is the question. So there's a very clever idea to do this. Like what you can simply do is, let's say you are fixing ing, right? And actually, I could not come up with this during the contest. Like I had to ask this to a friend who just became master today. So his contest like went pretty well. So he told me this idea that what you can simply do is, let's say you are iterating from I is equal to, like, I from 0 to n minus 1, right? 0 to n minus 1. And you are also fixing j. Like you are doing it in n square, right? N square into m, in fact. So you are fixing I and j. So what you can do is, um, you can simply like update only certain cells. Like what we can do is, let's say let's just have a test case for me to explain better. Let's take this test case only. 10101, 10101, 10100. Or actually, this is pretty trivial test case, so I won't take it. Let's take a tougher one where there are multiple rectangles and there are many possibilities. So let's take this one. It is pretty big, but okay. 11100, 10, 110, 11111, 01101, and 00111. So this is your input, right? And let us say I draw the answer matrix right here, and initially it is infinity for all. Like I am just drawing the answers. Now, actually, I will do it in 1D equivalent. Like, let's say you have this problem, okay? Like, I will just tell you a simpler problem in 1D, and we'll use that idea in 2D also, okay? So, guys, let's say you have an array, like a 1D array of length n, okay, which is called A, and initially all are infinity, okay? Then what you get is you will get q queries. of type r comma k. So in each query, what you have to do is basically if you have r comma k query, then you have to like for all I from 1 to r 1 to r, you have to set ai to min of ai comma k. Okay, so process q queries and finally give me the answer. So how do you do this? The problem is clear, guys, that you have an array initially or infinity, and you have to process q queries. Each query is of the form r comma k, where r comma k means that for each I from 1 to r, just take the minimum of ai with k. So for example, if I have, let's say, n equals to 5, and I have one query as 3 comma 10 and one more query as 2 comma 5, then initially I have or infinity, and then I will have like 3 comma 10 say I will have a 10 here. In first three indices I will have a 10, and using this 2 comma 5 query I will have a 5 here. So 5 5 10 infinity infinity. This is the error. So how do you solve this? Yeah, that was to give you some idea. मतलब eventually हम वही करने वाले हैं, but there is no magical standard DS for that. So can you guys think about how to solve this? Like basically r comma key means you have to take a prefix and do the operation on that prefix only. Like take the minimum with that. Like take the minimum with all of the elements. Take the min of all of elements with k. That's what the query is. So can you guys think of how to solve this? Mark right sides and process from right sides. Okay, I think what you like, your statement is not very rigorous, but I think I understand what you mean, and I think what you mean is right. Like I think what you mean is that whatever the queries are there, like let's say we have 3 comma 10 and 2 comma 5. That means in the first three elements we want to have 10 10, and in the first two elements we want to take the minimum with 5. So what we can do is um, just mark this, like instead of doing it for the first three, like for the entire prefix you want to do, right? But instead of doing that, just do it for, like, just mark a 10 right here, and just 2 comma 5 means just mark a 5 right here, right? And the others are still infinity. Okay, and then what you can do is you can move from right to left. Just move from right to left and take the suffix minimum. Like basically, uh, in the final array, your answer, this answer would be infinity. That is the minimum of this subarray. Then this answer would be the minimum of these two. This is infinity. Then this answer would be the minimum of these three values, which is 10. Then this answer would be the minimum of these four values, which is 5. And this answer would be the minimum of these five values, which is 5. So basically, what I did was I essentially propagated this value. Like if there was not a 5 here, this 10 would also be propagated to this side. Like what I'm just doing is I'm kind of taking the suffix minimum. I am propagating this value at the end. Like when I am getting the query, I am just putting that value on that particular index. And finally, when I am iterating through the array in reverse, I am propagating it also. So for example, if I have one more example, like let's say I have two queries, uh, 2 comma 5 and 3 comma 4. So I will put this 5 on second index and 4 on third index. And so when I take the suffix minimum, like there's to infinity. So when I take suffix minimum, so this is infinity, these two are infinity, then these three ka it is 4. Then again, these 4 ka it is 4 only. Because this 5 is greater than 4, right? And in Pancho ka bhi, it is 4 only. So this is the final answer. So I am essentially taking the suffix minimum. Okay. So we can extend this idea to 2D as well, actually. So what we actually do is we try to extend this idea to 2D. Like we had this example right here, right? So let's say I have my I right here and J right here, correct? So first of all, I will have these two ones. So I will update, like I want to update um, all of these cells, like all of these 6 cells with an area of 6. Like initially it is infinity, right? But I want to update it with 6. But I can't just brute force that, right? So what I'll actually do is I will only do it for the last. Like here, when I had this query, which was 1 to R, I only did it for the last element. Like I only placed this k. Like as you can see, when I had this r comma k query, I only placed this k on the rth index. That means on the end, I just placed it, right? So similarly here, um, I want to update in all the rows, right? Like in this row also I want to update. In this row also I want to update. But instead of that, I will just update the last row. So I will just update 6, 6, and 6, and I will still keep them infinity only. Okay. Then I will move my, and yeah, also one. Okay, so in these two rows, these were the only two 1 1 pairs, right? So my job is done for these two rows. So I will move my j down. Okay. So I have this now. So I have this one pair like this, uh, like this one and this one, right? So I will have to update, like for all these 9 cells, I'll have to update the answer to 9, right? Like the minimum of AI, comma 9. So for that, I will only update these 3 cells. So 999. Okay. And I don't have any more rectangles in this also. So I'll move to the next row. So I'll move this J downwards. So I move this J downwards. Do I have anything? I have only this pair of ones. So only a single pair can't do anything, right? And in the end, again, I have only this pair of ones, so it cannot do anything. So okay, for this I am done now, right? For this I am done. And now what I'll do is I will again take suffix minimum. Like I will try to propagate these values upwards. Like basically this is still infinity, infinity, infinity. Yeah, so now what I will do is I will try to just like I did here. Like here I propagated this 5 to the next one, right? So like I just took the suffix minimum. I mean the suffix minimum, right? So that's what you can do. Like here also, you can take the suffix minimum till ith row. Like don't propagate it upwards. Basically, since my I was here at 0, right? I equal to 0, and j was varying. Like I was fixed. I had fixed I equal to 0, and I was varying this j. That means my starting point was fixed, but the ending point was different, and that's kind of similar to what we had here. The starting point was one only. Okay, where did it go? Yeah, the starting point was one only, but the ending point was a variable. So we just propagated that value until the starting point using suffix minimum. So here also you can do the same thing. We can simply propagate these values upwards until this row, that is until ith row. Okay, but not above that. Okay, because all of these updates that we did, like this update that we did, this update that we did for 9, like this was for 6, this was for 9. So this actually started from this row only, as you can see. So do not propagate this above the ith row, but just do it till the ith row, because the starting point was ith row for all the updates, right? So we can simply update only this row and just propagate these updates upwards, and like this will take O of n into m time, right? O of n into m for propagation, right? And for every I, we are doing it once. Like for every I, we are doing it the propagation, and therefore it will take O of n square m for propagation, right? And you might ask that what about this thing? Like we are still, like when we are doing the updates, like let's say this is the rectangle. So if we want to update this entire thing with this area 6, then we are updating all the cells, right? So how much time will this take? So this will only take in total O of m time. Like for every ij pair, like let's say this was I equals to 0 and for j equal to 1, you have this rectangle right here. And let's say if these were also 1, then you would have this rectangle also right here. But in total, your entire update for one ij pair would just be O of n, right? So that's also O of n square n. And like for like when you are done with a single I, you will just propagate the values upwards, and that will take O of nm time, and you do that for every I. So that's also O of n square n. So everything in this process is O of n square n. And finally you will end up with a matrix which has all the updated values, and you can just print that. But just be sure to replace the infinities with zeros. Like they want us to print 0 where there is no rectangle possible. So if there's infinity at some place, just print 0, right? So this is the idea of suffix minimum. It is a pretty nice idea. So do you guys get this? Like n into 2n into 2n. Yeah, I mean, sure. Like you can say it. I mean, in big O notation, it is not. It doesn't matter, right? And it is big O of n square m only. Thank you, Sohani. I hope you understood it. Yeah, nice. Okay. So, guys, do you have any other doubts? Love your efforts. Thank you, Safwan. Clear. And actually, I don't have the code for this because I could not solve it in the contest. So, like, I'll have to absolve it, write the code, and I will share it in the description below, and you guys can see from there. Because, like, I think if you are attempting this 2300 problem, like, yeah, okay, it is not 2300. Okay, it is 2300 rated. So if you are trying to attempt this, then I think code to you can do it yourself also. So I won't explain that much, but I'll share the link anyways if you have some doubts. And if you still have anything a doubt about the code, then you can comment also, and I will reply. And if I don't reply on YouTube comment, then you can DM me, and I'll reply more probably. Don't DM on this account. This is my alt account. Like I did not give the contest using my main because it was CM, and I had to take the PCD of div 2, and I could not give div 2 using that account, so I used this one. And also my rating would get very bad. Like my rating would decrease if I gave contest using that account because I'm out of practice right now. So I'm trying to avoid. I mean, that's not something I would do normally, but anyways. All right, thank you. I guess this was pretty tough to understand also. So if you understood it, whoever of you guys understood it, kudos to you as well. So kudos to you. Anyways, so I'm assuming that you have no doubts. Uh, Maybe I can show the code also, like my friend's code. Maybe he became master today. This is the friend. Yeah, he became master. Nice. Maybe it can open. Let's try. Which contest is this? 2159. Okay. Yeah, this is the code. Okay, this is. I won't explain this code. Like, I did not see it initially before this thing, but it looks pretty bad. This is not how I would implement it. Like, it just looks pretty bad. I will share a nicer looking code for you guys. Anyways, thank you, Vishal. Okay, so let's end this now. Like, I'll see you guys next time. NCR. NCR was there. Maybe it was not used, like it is just in its template. Yeah, power factorial NCR. This was maybe in his template only. Every relevant bit of code is in the main function. Anyways, yeah. Okay, let us end it now. It's 2:30 a.m. I have something else to do. So let's end this. Thanks for watching, guys. Thanks for the appreciation also. And if there's any critical review, then you can post it in comments also. But just don't be rude. Okay. Anyways, let's end this. Good night. Bye bye. All right.